Another type of energy sources is renewable energy resources. Renewable energy resources are also known as non-conventional energy resources. These resources can be renewed, these resources can be replenished. That's why these resources are known as renewable energy resources. These are abundant in nature and these are inexpensive in nature. So we need to focus on renewable energy resources and we should move on towards renewable energy resources to get maximum energy from these resources. Non-conventional or renewable resources are energy from biomass, energy from waves, geothermal energy, tidal energy, solar energy, and wind energy. We will discuss briefly one by one each type of renewable resources of energy. Energy from biomass is another type of renewable energy resource. It can be renewed, it can be replenished, and it is found abundantly in nature. So we can use it for getting huge amounts of energy and inexpensive energy because it is abundant in nature, so it is inexpensive. Biomass is actually garbage. It is agricultural crops and residues or from sewage, from solid waste and animal residues, industrial residues, forestry crops and residues. These all are known as biomass and we can take energy from biomass. Biomass is around us. It is the dead trees, tree branches, leftover crops, wood chips, sawdust, yard clippings. These all are stuff around us known as biomass and that is actually garbage and we can take energy from this biomass and that is known as energy from biomass and that is renewable energy resource. Biomass is carried out in trucks to biomass power plant and there they are heated in furnace and due to their burning the heat produced can be utilized to boil water in the boiler and steam can be utilized to turn generators and turbines. Nowadays, we can also utilize plastics because plastics contain high energy content and we can get electricity from that energy of plastics and we can convert energy from plastic into electricity, synthetic gas, fuels and recycled feedstocks for new plastics. So we can utilize plastics as well. Poultry droppings from 785 million birds and dung from 72 million animals can produce biogas and that can generate heat and electricity. We can use technologies such as combustion, gasification, pyrolysis process to produce biomass energy, energy from biomass, around 81 million ton per annum biomass production and that can generate huge amount of energy. Bioenergy, energy from waves. Energy from waves is another type of renewable energy resource because it can be replenished, it can be renewed. That's why it is known as renewable energy resource. We can utilize wave energy to generate electricity. And we know that waves are caused by wind blowing across the ocean. Here we are using OWC device. OWC device is oscillating water column device to generate wind waves energy into electricity. So actually we are converting energy from waves into electricity. Here the structure of OWC is shown and it opens to the ocean below the water surface, and waves coming through this structure causes the water column to rise and fall. Due to rise and fall of water with the waves, the air in the top structure pressurizes and depressurizes. This in turn pushes and pulls air through a connected air turbine at the top of the structure, and it generates electricity. Geothermal energy. Geothermal energy is another type of renewable energy resource that can be renewed, that can be replenished. That's why it is known as renewable energy resource. Geothermal energy is basically energy inside the earth in the form of heat, and we know that earth is full of heat, and that heat energy can be converted into another forms of energy. And we have here a structure of geothermal power plant that converts geothermal energy into electricity. So for that we drill 1 or 2 miles well inside the earth. So wells are drilled deep inside the earth, and from there we can pump hot water. And we know that inside the earth there is high pressure, and this hot water is pumped through this deep inside the earth, and when it reaches the surface of the earth, pressure is reduced, and due to that hot water is converted into steam, and this steam is utilized to turn or to spin this turbine to convert or to generate electricity. So we get electricity, and geothermal energy is converted into electricity. And here in this cooling tower, steam cools off and condenses back to the water. So this cooled water is pumped back into the earth, and this process continues again. Geothermal power plants are placed where the earth is hot just below the surface, and that areas are having lots of springs, geysers, or volcanic activity. Tidal energy. Tidal energy is another form of renewable energy resource, and it can be renewed by nature itself. Tidal energy is energy from the tides, and we know that there are high and low tides. There are high and low tides. High tides are due to gravitational pull of both sun and moon, and low tides are due to Earth's rotational and gravitational power that pulls water down. So this movement of water from the changing tides is a natural form of kinetic energy. Here is a picture of tidal barrage, and original picture of tidal barrage is also shown here. It is a dam that utilizes the potential energy generated by the change in a height between high and low tides, and this energy can be utilized to turn a turbine or compress air, which will generate electricity. This picture shows the tidal energy technologies that are turbines to generate electricity from tidal energy. Solar energy. Solar energy is a renewable energy resource because it can be renewed by nature itself. So it is known as renewable energy resource, and it is mostly used energy resource in the world. Solar energy is basically energy from the light and heat of sun that can be utilized to generate electricity. It is inexpensive renewable energy resource. Its maintenance is easy, its operation is easy, and it can be used easily anywhere in the world. Solar panels are long lasting and they have very minimum cost and maintenance. Pakistan is blessed with greater sunshine duration. That's why it's good to use solar energy in Pakistan, and we should take advantage of this type of renewable energy resource. Wind energy is renewable energy resource. It is the energy from the winds. The kinetic energy of winds can be converted into mechanical energy, and windmills are installed in windy region. Their wind turbines convert wind energy into mechanical energy, and that can be utilized to generate electricity. Around 100 billion watts per year of power in the shape of wind energy is available on the earth. So we should take advantage of this renewable energy resource. Wind speed around 5 to 7 meter per second persists in the coastal regions of Sindh and Balochistan provinces with more than 20,000 megawatt of economically feasible wind power potential. So wind energy is inexpensive renewable energy resource, and we should take advantage of this energy resource. Conceptual questions. Question. A bucket is taken to the bottom of a well. Does the bucket possess any potential energy? Explain. Yes. Bucket possesses potential energy. When a bucket is taken to the bottom of a well, some work is done against the upthrust of water. This work done is stored in the form of potential energy in the bucket. We can also say that the bucket possesses some negative potential energy with reference to the ground level. So it's obvious that when we are moving the bucket into the well, so we are moving the bucket and we are doing work against the upthrust of water, because we are moving it against the upthrust of water. So we are doing some work done, and that work done is converted into potential energy in the bucket. So it possesses potential energy, and with reference to ground it possesses negative potential energy. Question. When an arrow is shot from its bow, it has kinetic energy. From where does it get the kinetic energy? Answer. When bow is stretched backward with arrow in it, the arrow gains elastic potential energy, because we are doing some work done to stretch it backward with arrow. So it has some elastic potential energy. Elastic potential energy stored in bow and arrow is equal to the work done to stretch the bow, because we are stretching the bow and we are doing some work done to stretch bow with arrow backward, and when we do some work done, that work done is converted into elastic potential energy. When arrow is shot, then its stored elastic potential energy converts into its kinetic energy. So that stored elastic potential energy is utilized into kinetic energy. Question. Does a hydrogen-filled balloon possess any potential energy? Explain. Answer. Yes, it possesses potential energy. Hydrogen-filled balloon moves up against the gravity, so it stores gravitational potential energy in it. It is doing work against gravity, and its position changes with respect to ground and potential energy increase. That is, potential energy is equals to mgh. So potential energy is directly proportional to the height from the ground. So because balloon moves up against the gravity, so it stores gravitational potential energy. Question: is kinetic energy is a vector quantity? Answer: no. Kinetic energy is a scalar quantity. We may express kinetic energy in terms of scalar product, that is, kinetic energy is equals to half mv square, and here v velocity is a vector quantity that can be written as dot product of velocity v into v, that gives v square. So when we put v square is equals to v dot product of velocity in equation number 1, we write it kinetic energy is equals to half m dot product of velocity v dot v, and here dot product gives us a scalar quantity, that is kinetic energy. Mass is scalar quantity, mass is constant, and half 1 by 2 is also constant, and here we have dot product of velocity v dot v, and we know that dot product of vector gives us a scalar quantity, so it means that kinetic energy is a scalar quantity. Question: what happens to kinetic energy of a bullet when it penetrates into a target? Answer: moving bullet possesses kinetic energy when it hits the target and penetrates. Some part of its kinetic energy is used against the friction provided by target material, because target material will apply some frictional force on the bullet, and that bullet will be doing some work done against that frictional force due to that target material, and it also dissipates energy in the form of heat and sound when bullet penetrates into the target. So some of its kinetic energy will be converted into friction work done against the friction, and some of kinetic energy will be converted into heat and sound. So work energy principle is equals to work done is equals to half m final velocity square minus half m initial velocity square. Here final velocity becomes equals to 0 because bullet penetrates into the target and finally it stops due to the target material, so final velocity of bullet is equals to 0, and we get work done is equals to minus half mvi square. Negative sign shows that kinetic energy is lost. This loss of kinetic energy is equal to work done to penetrate the bullet into target. Question: does the tension in the string of a swinging pendulum do any work? Explain. Here is a swinging pendulum and we need to calculate the work done by tension in the string of swinging pendulum. So answer is no, it does not do any work because the tension in the string does no work, because it is always perpendicular to the curved path or instantaneous displacement. We know the formula of work done, that is equals to Ft cos theta, because force and displacement is the dot product and dot product of force and displacement is equals to Ft cos theta. Here force is tension in the string and displacement is this instantaneous displacement in the curved path, and the angle between tension, the force in the string, and the displacement is 90 degree. So when we put theta is equals to 90 degree, that becomes cos 90 degree equals to 0 and we get work done is equals to 0. So this tension in the string of a swinging pendulum is not doing any work done. Question: a meteor when enters into the Earth's atmosphere burns. What happens to its energy? Answer: when meteor enters the Earth atmosphere, then air friction acts on it. The huge amount of energy is used against the resistive force of atmosphere in bringing the meteor to rest. The loss of kinetic energy appears in the form of heat energy, which burns the meteor to ashes. Question: what type of energy is stored in the spring of watch? Answer: a compressed spring of watch stores elastic potential energy in it, and elastic potential energy is equal to half kx square. This elastic potential energy stored in the spring is equal to the work done to compress the spring, because when we compress the spring we do some work done and that work done is converted into elastic potential energy equals to half kx square. Question. A man drops a cup from a certain height which breaks into pieces. What energy changes are involved? Answer. A cup thrown from certain height loses its gravitational potential energy and gains its kinetic energy. When it strikes the ground, then a part of its kinetic energy is used to break the cup and rest of energy converts into sound energy, kinetic energy of scattered moving pieces, and heat energy dissipated against friction. So these are the energy involved. Question. A man rowing boat upstream is at rest with respect to shore. Is he doing some work? Answer. No. No work is done as boat is at rest with respect to the shore. As boat is at rest with respect to the shore, so it covers no displacement with respect to the shore. Displacement is 0, and when we put displacement is equals to 0 in the formula of work done, so work done is equals to F multiplied by 0 cos theta, and that gives 0. So work is equals to 0, so there is no work done. Question. Why energy savers are used instead of normal bulbs? Answer. Energy savers are used instead of normal bulbs due to the following reasons. The consumption of energy in energy savers is far less than normal light bulbs. Energy savers produce very little amount of heat, while 98% of input is converted into heat in light bulbs. And energy savers produces light of high power and intensity as compared to normal light bulbs. That's why we use energy savers instead of normal bulbs.